So Shravan, the stage is yours.
Hello.
Hello, Shavan.
Hi. Can you enable screen sharing?
Okay. Andrew, I think you should make Shavan be the co-host, and then he could share the screen and turn on his camera.
Okay,
Yeah. Okay.
please try again.
Yeah.
Okay.
Thank
We
you,
can see
Andrew,
you.
for the introduction. Good afternoon, everyone. My name is Shravan, and I'm a fourth-year PhD student working in SMRT NTU Suburban Rail Corporation Lab in School of EEE. Well, when I got an offer letter from NTU, it was a very excited moment because first thing, I got admission in one of the best university, and the second thing is I'm going to work in a industrial project, which is a very rare opportunity for most of the researchers. So I mean, industrial projects are something, if you do any research contribution, the result could be seen in next 1-2 years. You can see a outcome of your result or research in a very short duration. So my project is more on signaling system and signaling problems in the railway systems. So let me give you a little background about what is a signaling system. Why does a train need some kind of wireless signaling system? So in the last 100, 200 years, the railways were there, and how people were finding out where the rail is located on the track. They were using a fixed block system technology. In this technology, what they do is they divide the entire train track into blocks. Each block is of length 1 to 3 kilometer segment of the track. So when a train enters a particular block or a segment of the track, using the lock circuits on the track, so the train operator, the train driver, and the operators know the train is at a particular block. To be on the safer side, the train operators make sure that the three blocks, at least three blocks which are nearby the train, are noticed to be occupied so that no other train enter these blocks. So here, every train, it is occupying 10 kilometers, about a 10-kilometer block on a track for its journey. And because of this, there is a lag between trains and the frequency of the trains is very low, as we need to increase the frequency of the train so that more commuters can use the railway systems for their journeys. They came up with a new technology which is called communication based train control, which is nothing but using a wireless technology for train communication system, using a wireless system to locate where the train is with a lot of precision. So if you look into this video on your right side, it says like communication based train control, CBTC. Here the blocks are moving. The entire track is distributed with transponders, or which are also called beacons. So when a train is at a particular beacon or a transponder, it it detects the location, and the train driver and the train's control system knows that it is at that particular X location. And this location information and the speed of the train are transferred to the MRT operators or the wayside control systems. You can see in the MRT stations or any other control system centers of the MRTs. So this information is very critical, like knowing the accurate location of the train on the track in the accuracy of 2 to 5 meters is very critical, because they can control the speed of the train and that they can control the speed of the upcoming trains as well. So this is very interesting phenomena, because people cannot use GPS kind of system in trains, as the trains move along the tunnel areas in the MRT stations where the satellite signal cannot reach the train. So they came up with this system which is called communication-based train control. Train identifies its location and transfers this location information to wayside. Very exciting project, right? My work was to make sure that the train signaling system works reliably. So if you look at the problem statement of my PhD research work, So here in this figure, you can see that there is a train and the signals being reached from the train to the access point and from the access point to the train. It is a two-way communication system. So when the train signal failure occurs, let's imagine there is a signal failure because of coverage or anything. So if the train signal failure occurs, the train loses the information about the upcoming trains and the trains behind it. And it cannot transfer its location information to the other trains and the operators. So this problem is very challenging because once the train loses the signal, it doesn't know where it is and it doesn't know how to move with what speed it should go ahead. So in this case, if there is a signal failure for 1 second to 3 seconds, the control system in the trains, which are called automatic train protection systems, they trigger the emergency brake and the train system comes to an halt until and unless some engineers go down and do the maintenance or some kind of troubleshooting is done. Well, after doing some kind of literature review and like speaking with different engineers in this field and knowing a lot about different failure cases around the globe, I realized that there are two main reasons for train signal failure. One is the poor signal strength along the train tracks. If the signal quality is low, you cannot transfer the information or receive that information. And the second problem is wireless interference. If these train signals get interfered by any external signals like Wi-Fi or any jamming signals, the signal failure happens. So it is a very interesting research problem to work on. If I solve this problem, then there will be no more signal failures. That was my motivation when I was working on this project in the beginning days. So as a preliminary study, I used multiple simulation tools, mathematical models, and did some kind of modulation, did some kind of simulations, where on the left side, you can see an animation. There is a radio system or the transmitter, which is placed inside a tunnel, and the train is moving away from this transmitter. You can see multiple colorful lines reaching the train, which are known to be multipath or reflections from the walls of the tunnel and reflections from the surface and roof of the tunnel. So because of these reflections, when a signal reaches the train, it is not a single accurate or single quantity. It varies over multiple values. So what happens is there is a huge fluctuation and there could be a deep signal loss as well because of this multipath propagation. So as the size of the tunnel changes, the effect of signaling fluctuation increases, and there could be few locations in the tunnels where you drastically experience signal failures. So this is a very interesting thing. I did some other simulations to know where are these reflections coming from, at what distance, what location, and how these reflections vary for different size tunnels. So it was very interesting. I compared for 50 meters when the train is away, like 150 meters away from the transmitter, 250, 350. So I got to know there is a heavy fluctuations when the train is close to the transmitter. This is what I realized about the importance of multipath effect in the tunnels in my first semester of my first year. So I was much interested in tunnels, and then I went through like what happens in a curved tunnel. Okay, if there is a straight tunnel, the reflections are consistent. But what happens in a curved tunnel? Curved tunnels are more worse because whenever there is a curvature, the direct signal paths are being blocked. On the left side, you can see the anime. On the right side, the signal strength. So the sharper the tunnel curvature, the higher the loss it is. So I was very much excited about all these results, all these findings, what I got in my first semester and maybe just after my first semester. So by that time, there was no funding for the project which I'm working on. So I went to one of the like heads of the lab or someone from the who evaluate the project funding. I said, look, I got very interesting results in my preliminary study. I did the literature review. There is a signaling problem and you can solve it. You can solve it if you do some kind of measurements, modeling, analysis, use some machine learning techniques as well. But I don't know, that was not a good day for me, because when I explained all these things, I think the opposite person may not be in good mood. So he said like, hey, look, we already have a good backup system, and I don't think we can give any funding for this project in the present scenario. Well, I said to him, hey, look, I came from India. I came here to do PhD, and this is my research problem, which was given to me by my professor on my first day of PhD. From that day, I'm continuously working on this project. So after explaining, after having a discussion, but still the conversation ended up saying like, he started suggesting me like, you can think of some other project to finish off your PhD, but I don't think we are much interested in this problem because we already have some troubleshooting techniques. So it was too late for me to know about these things, but I spent more than 8, 9 months in this. And then the next day, I reached my boss, and this was my expression. My 8 months effort was gone and has nothing to do now. So my supervisor, like Professor Lee, she's very relaxed person, and I was just crying, and I was saying whatever I have done in 8 months is no more useful for anyone. I need to start everything from the beginning. So this was her expression when I was saying all these things. And yeah, this was her expression when I explained about the problem, and they were just laughing because they see these things in a, like, these are all problems which every researcher face. You could have funding, you may not have funding, and things change. And here I felt like my 8 months are gone. What should I do now? Well, then she said like, look, don't worry, relax, we have some other project coming up, which is a very interesting one as well, which is called vehicle to infrastructure communication technology, and which is on uh, sea sea to land communication. If you are in a going on a yacht, or in a cargo ship, or in any kind of vehicle which moves in water, you need some kind of communication system there as well. Here the communication system is more required to make sure you safely travel, and if someone attacks, how you convey the information to maritime system or the coast guards. So this is a new journey and new project. I got one more opportunity, and this is an industrial project as well. Whatever I do here, it is readily being used by people. So this communication is very crucial for providing entertainment on sea, providing safety, providing less traffic congestion on sea, because Singapore waters are known to be one of the heavily crowded or high traffic congestion waters. So here you are using a technology called vehicle to infrastructure, which is more dominantly used in autonomous vehicles, but we thought of doing it on sea. So it was an interesting project. We made a start. I prepared the whatever hardware measurement system we required for the experiment, did the planning, which route we can take and where we can go. So we rented a yacht, which you can see in the picture, and the transmitter setup, the radio transmitter setup, is placed on Lazarus Island, one of the islands in Singapore. So the plan was we should travel in along the Singapore Strait, Singapore water, and measure the quality of the signal. If you have a transmitter on the road on the land in Lazarus Island, what could be the coverage area which you can achieve? And is there a possibility of transferring video signal from land to sea, and which can be received with a better reliability? So that is what a vehicle to infrastructure technology is, like transfer information from land or from some other vehicle to one more vehicle. So this was the route which we have taken. We traveled away from the Lazarus Island, like 13.2 kilometers. One more interesting project, and it was more or less a very successful one, we could say. And we installed the what we call the transmitter setup on the Lazarus Island. This is the picture. The antennas you can see, and a computer and a video transmitting system, and some other data transmitting systems on Lazarus Island. And the receiver setup is here. You can see 6 antennas, like 3 of them are known to be like directional antennas, and 3 other are called shark fin antennas, which are used on cars to know the GPS, to capture the GPS signals. So yeah, we installed everything and the setup was ready. My job was more on calculating the link budget, which is nothing but what could be the overall coverage area if you install a vehicle to infrastructure technology. So how good the signal quality will be along the sea. So here is Professor Lee, and the setup is ready. We are logging the data and moving away from land. And a small comparison, like what happens if you use a omnidirectional antenna, the antenna which can capture signals from all the directions, and a directional antenna which can capture signals in a very narrow direction but with a higher amplifying gain, antenna gain, you can say. So for the first 3 kilometers, yeah, video signal, video transmission is fantastic. But after 3 kilometers, as I said earlier, the Singapore waters are the most busiest waters. There's a lot of traffic congestion, and it's you can see a huge traffic when you're moving ahead. So you need to take a lot of breaks when you're moving. So there was a blockage. We took a turn and we went ahead. So this blockage is very interesting for next 5-10 minutes of my presentation. Well, after doing the measurement, I did the modeling and we realized that water, the water reflects the signals, which causes a dip. You can see a dip in the signal quality when it is below 2 kilometers. X-axis is distance in kilometers and y-axis is received signal quality in dBm. So you can see a dip which says that, when you are closer to the land, which is like around 1 kilometer, the sea reflections are stronger, which can cause the drop in signal quality. So it is called destructive interference, and you get constructive interference as well. Like the signal quality is better than you expect because this reflections will help and enhance the signals as well. So something interesting happened. That was a very good experiment, successful experiment. And we finished the experiment, did the data logging, and we were relaxed, so enjoying the yacht journey on sea. So I noticed that there was a police vehicle following or coming along. It is the first time for me to see a police vehicle on sea, and it is in Singapore. So I was taking pictures, and everyone in our team were taking pictures, selfies. Well, after some time, one of the police officer came on yacht, and yeah, we thought it's a general checking, and we thought, okay, let's take a selfie. I went to the police officer. I said, like, I'm Shravan, PhD student from NTU. Nice to meet you. And surprisingly, his reply was illegal immigrants. He said, without the permission of the country's body authorities, you moved away from Singapore waters, entered Indonesian waters, and came back to Singapore waters again without any government permission. So if you look at my results here, there is a blockage. When we were at 3 kilometers away from the sea, there was a heavy traffic congestion and there was a huge cargo ship which was moving away closer to our yacht. So when a yacht is closer to a huge cargo ship, as the yacht is a lighter body, it fluctuates. It fluctuates a lot. And I was with the receiver setup and I informed the driver, the captain of the yacht, saying that, hey, if this continues for next 5 to 10 minutes, the expensive receiver setup will fall in water and I am not going to jump in water to save those equipment. And it's your responsibility to make a turn, overtake this huge cargo ship and get back to a stable state where we can do the measurement. Well, it was a tense moment. The fluctuations were there, and he said, okay, I'll do something. Just relax, just relax. So he took a turn, but unknowingly, this turn was very big, and we entered Singapore waters, which no one knows there. And the Singapore police, they stopped us, they interrogated us, they were very nice, I would say, with a lot of respect. The discussion was And by the time it was 3 hours we were on sea in all these discussions. By the time we came to land, the entire ICA immigration team was there, and again interrogations and everything was going on. So it is a different experience, you know. You went there to do a measurement, and suddenly, unknowingly, you entered some other country and you came back without any permission. Well, I was panicked. I went to Prof Lee. Hey, look, Prof, I was given a SMRT project, and then I came into this sea to land, and now immigrants, illegal immigrants. This was my expression. And she said, like, relax, nothing happens. Just go, do your work, and I'll speak with everyone. So yeah, this is what happening, and the project was given over to some other team because I got some delayed or some other issues. By the time the SMRT engineers and the SMRT team, they came back to us and said, hey, look, we are interested in your project. Whatever the preliminary results which you have shown in like 3 months before, they were good. We want to discuss about the funding of the project. You know, unexpected. This is a very unexpected journey. You spent 8 months, you learned everything, you started a project, did preliminary, and suddenly you went to sea to land testing. And testing was successful. You became an illegal immigrant, but luckily everything was good enough. We came out of that problem, and then you are back to the same original project where you have started your journey. So I was very happy. I forgot about everything what happened. Now I got one more chance, and whatever I thought of doing here, it is going to happen. My initial plans for the PhD. So as a initial step, whatever simulations we have done, we should show them as reality. Whatever fluctuations of the received signal in the tunnels I have shown you in the first, second slides, whether they are true or not, we should validate, prove the idea what we are saying. So I was alone in the project team, only one. So, but we already had some measurement equipment in Professor Lee's team. So I developed the measurement setup, whatever we can do, the programs to connect a hardware to a software. How do you do data logging, and how many meters you'll be measuring the data. So this is the tunnel environment. We got the permission to enter the tunnel. So you cannot enter the tunnels anytime because the trains are moving. And the SMRT operators stop the train services after 12:30 midnight. So we can enter the tunnels after 1 a.m., 1:30 a.m. Uh, Getting this permission is very difficult because we need to give a lot of justifications, doing risk assessment, explaining step by step what we are doing and what are the things which are entering the tunnel. It's a 3 months process. And I got these 3 months to develop the hardware and decide at which locations I'm going to do the measurements in the tunnel. So we don't get much privilege of using multiple days measurements because if you want to access the tunnel to do any measurements, they should suspend the maintenance hours, which is not at all acceptable by many other engineers or engineering teams, and it may harm the reliability of the train systems as well. So hardly we got 2 days. So I prepared the setup. I was the only one. Like I make sure what size the antenna should be and how you should move, what is there, and how heavy is the equipment. You don't have power supply in the tunnels, so you should use your own batteries, UPS, and you're moving the equipment. So you should make sure everything goes well. So I prepared well. I spent like almost 2 months in laboratory every day working on the setup, and it was very important for me to make sure the system works well inside the tunnel, and I get the same results which I'm expecting from the theory what I have read. So I planned this experiment setup, which is the idea is we should start from the Paya MRT stations with the setup, and the transmitting system is fixed at around 500 meters from the Paya MRT station. And then with the receiver, we will be moving towards the transmitting system, capturing the signals, and vacate from Dakota MRT station. So it's more or less 1.5 kilometer. So as I said earlier, I was the only one in the team, and I prepared the hardware setup. And we asked one of our seniors, like my senior, Dr. Shilpa Mananda, who works in some other project. I asked her, can you please help me with the setup, because we need at least two people to manage, one to manage the transmitter and the other to move the receiver. Luckily, Professor Lee said, I want to join you people for the testing. So she was there with us in the tunnels at night. So as I instructed Shilpa Manandar what to do, but I said, hey, when you fix the transmitter, you switch on the power, and when you switch on the radiating system of the transmitter, you inform me that the setup is ready. You can start moving from Paya Lebar MRT station because you can capture the signal now. It was the first time I was using walkie-talkies. Well, Shilpa and I decided we will use walkie-talkie in the tunnels because no cellular signals there. So I said, like, when you are ready, give me a message on walkie-talkie. And after watching many movies, I realized once you finish your talk on walkie-talkie, you should say over. I got a message from SMRT engineer saying that your walkie-talkie is not working and your senior want to speak with you on my walkie-talkie. So the SMRT engineer hand over the walkie-talkie to me, and I can hear to my senior's voice, Shilpa, saying, can you ask Shravan to come over? Then I said, yes, Shilpa, Shravan over. And again, she said, can you ask Shravan to come over? Then I said, yes, Shilpa, is there any problem? Over. Then she again repeated, can you ask Shravan to come over? Because we have just 3 hours to finish off the experiment. So I was worried that system has some issue at the transmitter. She's unable to configure it. So I should read the transmitter setup, repair it, and come back. So I hand over my walkie-talkie to SMRT engineers, and the Professor Lee was there at the receiver. So I started running 1 kilometer, almost 1 kilometer inside the tunnel at 1:30 a.m. just to check whether the transmitter is working or not. By the time I reached the transmitter setup, it took like 10-15 minutes run with the heavy engineering shoes and the torchlight on your head. Shilpa said, hey, I was saying the setup was ready. You come over on walkie-talkie. I didn't ask you to come over to the transmitter setup. This was my expression when I was in front of the transmitter, because I was counting every minute. We just have 3 hours to finish off the test. Again, I ran back to the receiver setup where Professor Lee was standing, and she started initial testing as well. When I went back, I heard this from Professor Lee. What happened? It was working till now, but suddenly measurement setup did not work. No, I ran 2 kilometers on the tunnel, 1:30 a.m. and I was super tense, super anxiety, I can say, like, because I spent last 2 months and this was a very important day for me to make sure that setup works well and receive the signal. As I said, I was tired, exhausted. I'm a morning person, but I'm awake at night time. So Prof. Lee was asking, what can we do now? The easiest solution is when a system fails, you restart everything. Just press a restart button. So I said, restart. And Prof. Lee restart, but when we restart the setup, it took almost 30 minutes to reboot. I made my mind the experiment failed, and I was very weak and tensed. And Prof. Lee looked at me and said, hey, look, you relax, you stand back. I'll look into this system and I'll make it work. Whenever we are planning an experiment, we always have a backup plan. We always have a troubleshooting documentation system. If something fails, what you should do next. If you watch air crash investigation, you see how a pilot responds if something fails. We have a similar procedure. But in this case, what I have done is I bypassed everything and I said, like, just restart the setup. That was my mistake, which I would have not done. Then Prof. Lee, she was very patient there. She did not blame me anything, and she took over the experiment. The 3 hours I was just standing behind her, and she was moving, and the other FIP student was helping. So after finishing the experiment, it was successful at the end. And finishing the experiment, when we unpacked, it was 5 a.m. Prof. Lee was sitting in the cab in the back seat and I was in the front seat, and I was waiting to hear that, "Hey Shravan, how did the experiment setup fail? What happened? You said 2 months is enough to prepare the setup." And I worked with many other people before coming to NTU, and I know like people get very short tempered when they see some kind of experiment failure like this on a critical, very important day. But she did not say anything. And the next day I went to my room and I was thinking, now she'll call me and ask, how did the setup fail? No. 2 days passed, no. But after 1 week, we had one more setup, and she asked like, "What about the next setup coming? Tests coming up? Are you ready?" Then this time I made my mind. So my boss protected me when I failed. She did not blame me. She took over all the blame on her and took over the responsibility to prove that the test is successful. So what I have done was I prepared myself like I should awake in night time, do the testing uh, in School of Tripoli. We have a corridor in B5, basement 5. At the same time, what we enter the tunnels like 1 a.m. to 4 a.m. I alone took the transmitter and receiver setup and did all the testings, moving the equipment in different ways so that it won't fail on the next day. And I moved the equipment in the car parking area, a different area, so that I should make sure that I am super active in between 1 a.m. to 4 a.m. and I will follow the troubleshooting things if anything fails. This was very crucial for me because I need to prove myself when my boss trusted me, did not give the blame for the failure of the experiment in the first test. So next day I informed my senior as well. If this time walkie-talkie issue, no more. You just start, and by some means you send me a message or send someone to inform me, but we'll just start receiving. I'm not going to run again. Next day, the experiment was successful, no problem at all. And whatever we proposed in our project proposal, like there will be a fluctuation and there will be multipath effect and there will be a wave guiding effect, we were able to prove that. And one more interesting thing, what we concluded from this measurement setup was, if there is a curved tunnel, the loss is super high. Straight tunnel enhances the signal, improves the signal quality, but the curved tunnels degrades. The loss in the curved tunnel is 3 times more than a straight tunnel. What it means is, if you are having a 10-kilometer straight tunnel section, you need 10 access point to the radio system to work. But if the same system to work in a curved segment of 10 kilometers, you should have at least 30 access points, 30 radio points distributed along the track. So this was a very interesting experience, I would say. And after that, we did multiple measurement tests on we installed the setup on the train. We traveled around east-west line. We traveled along north-south line. We captured the signals to study, is there any interference issue? What kind of signals are disturbing the CBTC or the train signals? Why does the signal failure happen? So it was like spectrum monitoring in wireless communication terminology to know how the radio spectrum is being used in the railway systems.
Here I'm using a waterfall diagram to explain the spectrum monitoring.
So these are a few results what we get. So on the right side, you can see a picture which says like you encounter wireless LAN signals, which are nothing but Wi-Fi signals. And there are wireless CCTV signals and multiple other signals. And the train signal, which is nothing but a CBTC signal, is occupying the spectrum. So the conclusion of the story is the CBTC signal, what are the train signals, are being interfered by Wi-Fi signals and the CCTV signals and many other signals, which are degrading the signal quality and causing signal failure. So we looked at the entire measurement track. If you see what is the effect along the train track. So when the train is in industrial area, if you're on east-west line, like Tuas Link until Jukun, it's more industrial area, no more housing buildings, no more much Wi-Fi usage. The effect is very low in industrial area. And when the train enters the urban areas like Boonlay, Lakeside, and many different urban locations of train route, the effect is high because of interference from the shopping malls, hospitals, the Wi-Fi system in the MRT stations. And when the train enters the tunnel, when the train is in between the MRT stations, the effect is very low because there is no external interference much coming from outside the tunnel. But when the train is inside the MRT, at the MRT station, stop, the effect is high. The reason for this is whatever the signals which are being radiated inside the underground MRT system, they sustain for a longer distance because of multipath effect. The signal quality increases itself. So later stage, I developed a intelligent signal identification algorithm, which is using the spectral signature of a particular signal, like maybe Wi-Fi, train signals, CBTC, and CCTV signals. If you know the signature of these signals and you do some kind of convolution and calculate the distance between the measured spectrum and the spectral signature, if there is a better match, you can identify those signals. Rather manually detecting those signals, which is going on in today's infrastructure, we came up with an algorithm which does it automatic. You just input the spectrum. It says, hey, your CBTC, your train signal has this quality. And at this location, there is a Wi-Fi signal as well, which is disturbing your train signal. And the next thing what we have done was when the train is stopped at an MRT station, you receive the train signal from something called access point. But from our analysis, we realized that these access points, which should radiate a good train signal, are radiating the interference signal as well, which is considered as interference signal from the access point on the adjacent platform. So there's some kind of interference as well. We did some kind of data mining, data analysis, and use clustering techniques. I would say we use k-means clustering to cluster the entire data and realize what is the source of each signal which we are receiving. And k-mean GMM Gaussian mixture model is better than k-mean because most of the radio systems signal quality you represent by a Gaussian curve. And then we use some kind of plot which is called violin plot, which is a very interesting plot, I can say, which gives you a additional new dimension how you look at the measurement data. And so by using this, we could conclude that which signal is from which source. This is very important in evaluating the signal quality in the train systems. So to summarize whatever I have done in PhD, within 3 minutes, I have given a presentation or a talk in a 3-minute thesis competition in School of Tripoli graduate student conference, one of the graduate student conference this year. So I would like to play this video.
In Singapore, on an average, 3.3 million people use train services every day. Let us imagine we are all sitting on a train and the train gave a sudden break and stop. We all have one question. Why did the train stop? Who is stopping the train? Is there a Spider-Man on the map? Oh, is it a signal failure? But why does these signal failure happen? My research work started with this question. These trains are automated. They trigger the emergency brake when a train fails to transmit or receive the train control information signals to the upcoming trains and the MRT operator. After reviewing different train signal failure cases all over the globe, I realized that there are two main reasons for a train signal failure. Number one, poor network coverage along the train tracks. This happens mainly in complex tunnel environments. To study this, we went into SMRT tunnels, performed signal quality measurements. After analyzing and plotting those results, we realized that the curvature of the tunnels degrades the signal quality 3 times more compared to open area. This information is very critical in deploying additional access points along the tunnel to improve the signal quality and eliminate poor network coverage problems. The second main reason for train signal failures is wireless interference everywhere. These trains, they use license-free frequency band, which is also used by Wi-Fi, wireless CCTVs, Bluetooth, and many other wireless devices. The train signal failure occurs when a train signal is interfered by a stronger external signal. Just imagine, even after knowing that these signals are harming brain signals every day, every time, continuously, we are unable to eliminate them because of many practical reasons. But we came up with a solution. By capturing all the signals from the brain and using an artificial intelligence technique in predicting the risk of interference and the sources of interference and passing this predicted information to the MRT operator in real time so that the operator can use this information and take precautionary measures before a train signal failure occurs. My research contribution is towards ensuring good train signal quality and predicting the risk of interference. Not just to avoid signal failures, but to save your time and your lives. Thank you.
Well, this was the 3MT competition. I got audience best choice award and third place in the competition. Well, I want to share something else. Until now, I just discussed about my research project and what happened, what was so interesting about my PhD journey in a industrial project, corporate lab project. So I have some suggestion for maybe for new researchers here who are in the conference. So on the left side, you see a raw data set, A, B, C, D, E, F, G. There are different data sets, and this data is varying over time. For time t0, it is in a different state where they all look same, but at time t1, they all change, and there's a different pattern. So when you want to know what is there in this data as a researcher or as a layman, what do you know from this? You just do a box plot, or you just summarize the data into calculating mean value, maximum, minimum, first quartile, third quartile, or maybe outliers. This is what you look. But when you look at the box plot over T1 time and T2 time, even though there is a change in data, change in raw data, with your statistical summary, you won't get to know what is going on in the real data. So this is mostly done by engineers or mostly done by all the beginners, I would say. But when you take a additional step where you can look into a violin plot. Violin plot is a sum of a box plot and a probability density function on the box plot. If you look at the vertical way, it looks like a Gaussian in time t1, and as time t2 comes in, the density function's shape is changed. So what is happening here is earlier the data was distributed over a Gaussian. You can represent the data using one Gaussian with mean and variance. But at time t2, what happened was there were changes in the data. The single Gaussian looks like a multi-Gaussian, which is called multi-model. A single Gaussian in the beginning first stage became a multi-Gaussian model, which is called uh, multi-model or data set. And to model this kind of data, either you use multiple Gaussians and use the mixing parameter, and which is called Gaussian mixture model, or else you cluster the data into using different clustering techniques and analyze each and every segment. The reason why I'm showing this example is if you are an engineer or if you are just a statistical analyst, you either look into the raw data, try to get conclusions from your scatter plot, or at max you go into the box plot and take out the summary of the data. But when you do some kind of interest in taking a new dimension, looking into a new dimension, you plot a probability density function, compare them with different data sets, and draw up some conclusions. So to look at a new dimension, you should make a first step. Making a first step is very painful because everyone is doing box plot or statistical summary, and you want to keep extra effort, and where you don't know whether this kind of plot will work for your data or not, and whether you're going to get some additional result or not. So if you want to look at new dimension, you should make a first step, which is very, very painful as a researcher. And once you do take out this first step, you are unique. You have some new ideas come in, and you can think of solutions as well. There's a very good saying, like, even a strongest soldier in a battle struggle to make his first step in the battlefield. So be a brave soldier and always try to look at a new dimension of the problem. So what is PhD life? If I want to summarize the PhD life into some kind of statistical distribution or data distributions, what can I say? Because this is a machine learning and data analytics club and AI conference. So when I joined PhD program, and before I joined, I felt it will be uniform. I'll be happy for most of the time. The consistency will be there. The same thing. I write papers, I do simulations and modeling, and report my boss, and the papers get published. I'm happy, and this is what I expected. And your family, your friend, everyone except your life will be uniform entire the time. So what in reality after my first semester I understood was, you know, life is more like a Gaussian curve in PhD. For after mean and before mean, like happiness can be happiness, and maybe you're sad for 50% of the time and happy 50% of the time. But when I realized that, the project funding was not there and things are not going my way, when I said to my friends, and they said, like, this could be skewed, not normal distribution. This could be skewed. You have more problems than less happiness. So this is kind of skewed distribution. But after my first year and second year, maybe qualifying exam, I realized that, yeah, it's more or less Gaussian, man. There are few problems which you encounter, which are like, which just shoot out, and you can say this is a edge peak model, edge peak data distribution. You're happy and sad, like it is more or less Gaussian, but there is some time in the PhD journey where it is edge peak. And in my third year, I realized that, oh no, this is a bi-model. The happy time of the PhD journey is half, but it is a other Gaussian model. And the sad time or the struggling time, what you can say, a challenging time, is the other half, which is also a Gaussian with a different mean and variance. But in my final year, I would say that it is neither binomial, edge, skewed, normal, uniform. It is more like a comb distribution model where you have two Gaussians which are overlapping. And you don't know what is the interesting challenge which knock your door next day. You feel like, oh, I can do a curve fitting. Single curve fitting will never fit a PhD life. It is a mixture of multiple models. I would say that this is a comb distribution model, if you ask me, PhD life. And this is some philosophy, like people say things happen for a reason. Things are random and meaningless. Things, what things? Nobody told me about anything. This is what you feel in midway of your PhD journey. But as you encounter more challenges, you solve them and you become stronger and stronger. I want to share some kind of what kind of motivation I got to start my PhD journey. On the left side, you see Dr. Amar Bose. He's a former MIT professor, and he did his PhD in MIT as well. One day he was traveling in an aeroplane 30 years before, and he was listening to music. As the aeroplanes at that time, like they were making a lot of engine noise, he could not enjoy the music. So it was a disturbing journey for him. So he was very disappointed. In his remaining journey duration, as he is an electrical engineer, he opened his rough book or notebook and started drawing a block diagram, thinking about how can I use a external noise and send it to a filter, modify it, and combine it with the signal which I'm receiving at my ear from the headphones, and combine these two signals and get out a noise-free signal. And the idea is active noise cancellation. The system dynamically changes over time, uses the outside noise, and filtered out the noise which is present in the signal which you are hearing in the headphone. This was a brilliant idea. This block diagram, he gave it to his wife when he reached his hometown. And she's also a researcher. She was surprised, what is this man brought for me when he went overseas? A block diagram? a funny thing happened. But this active noise cancellation headphone, it's not just about a comfort. It's about life for many people who are deaf. My grandpa was deaf, he could not hear, and he was not happy in using a hearing aid because a hearing aid just amplifies the signal which is outside your ear. But this system reduces the noise and amplifies the signal. So he got this idea 30 years before. He spent next 30 years working on this idea, demonstrating this idea, developing models for this idea, doing the lab experiments, and he ended up with a beautiful research outcome, which is Bose headphone and Bose sound systems, which not just provides entertainment but help many people. So I want to play this a short video, 30-second video. Maybe you get some kind of inspiration.
Again, and I'll come back to this again and again and again, is try to, whatever job you're given, and that wasn't one that I looked forward to, ask yourself, how can I do that job better, in fact, than it has ever been done before?
So yeah, this is the motivational words, I would say. Before I joined the PhD, I listened to this. And in my PhD journey, whenever I get some tough days, I'll go back to this video, keep it in a loop and listen again and again. He passed away, unfortunately, but his idea, his research work came up as a product which is helping many unfortunate people in their everyday life. He is not there, but his idea as a research outcome is there in many people's life. No one knows, who is this guy. This is my favorite headphone. Like it's my motivation always. I carry most of the time. So he said that I really wanted to do research that has never changed. From the day one he started his grad studies, the only thing what he had was thinking about ideas and how an idea lead to a solution. That's all from me. Thank you very much for giving me an opportunity and patiently listening to me in my interesting PhD journey in the industrial project. And thank you for SMRT NTU Corp Lab, which funded my PhD journey. And I'm very much thankful to Professor Ihui Lee. She handled me really well in my tough days. I was lucky to get an opportunity to work under her. And I would like to take a few questions if you have any, please.
So, yes, thank you, Shravan, for the informative and insightful sharing on your PhD journey. So, yeah, there are some questions from the participants. So, the first one is, what advice would you give a first-year PhD student? Thank you.
Yeah. So, if you are in a first year in any specialization, just try to be keep less expectations about your future and do all the basic coursework. Learn the programming skills which are required for your PhD journey. Learn about the softwares which you are going to use in your PhD. Know about whatever interesting things coming up, like new hardware, new equipment, and always be active. Be an active learner. Look into the courses on Coursera and different platforms. And whenever there is a seminar or webinar, just go there. You don't know when a new idea comes into your mind and you'll be working on that. So even a small idea can change your research work and research direction. Just open your eyes, open your ears and listen to every idea what you hear from outside. Yeah.
Okay, thank you for the advice. And there's another question. What is a day as a PhD student like? Can you describe it?
Yeah. In my life, first thing I do, I wake up, I'm a morning person. I wake up very early, like 4:30, 5 o'clock. I do some kind of meditation or something and have my coffee and come to lab. And we have a routine because every supervisor has some kind of weekly meeting schedule. So we need to update them every week. So as a PhD student, every day I had like, what can I do something new today? What can I do a small incremental work in my PhD work, which can show some kind of progress, even though I may fail, but my everyday works like, what can I do something new, learn something new. But please don't think that PhD life is very boring. We have a lot of fun as well. I worked as a graduate student club president. I do salsa, I go for swimming, I did marathon with my supervisor, and we had a lot of fun, like dancing, singing, parties, everything are there. But the first things first, whether you are enjoying your research or not. If you are not enjoying, you feel like bored, take a break, go out, throw a party, or reach someone, your friends, and make some party.
I see. Interesting. Okay, and yeah, I also have a question for myself. So, for myself, what do you think is how do you know that you are suitable for a PhD? Because I know that I think not all people are like suitable for a PhD, but like yeah, how do you
Very good
like what
question.
decides you to be a PhD, or like what are the factors that you consider when you decide to do a PhD?
Sure. So it's a very good question. Thank you for the question. So you treat PhD as a degree where you are enhancing your skills, enhancing your research skills, where you can think about ideas and understand the ideas of other researchers. You see a PhD as a journey of learning rather than you become an Einstein after your PhD, or you become something, a Nobel laureate just after your 3 years. Let's come back to the basic. PhD is a degree program where you are modeled as a specialist in that particular field. So by the end of your PhD, you are supposed to know the basics, stronger basics of that specialization program, and try to be an expert in that field as you read as much as you can. And there is no evaluation metric, because every PhD student's journey is different, but the destination is you are receiving a degree. So in the learning journey, you make sure you fill your bag with as many skills as you can: leadership skills, networking skills, presentation skills, research writing skills, and whatever skills you can, just fill your bag with all these skills. Yeah. So try to keep it simple. Nothing extraordinary. You are improving your skills.
Okay, thank you for the answer.
Yeah.
So yeah, that will wrap up our research graduate sharing session. So thanks once again, thanks Shravan for attending this graduate sharing session and for your sharing. So yeah, see you on the next session.
Yeah.
So after this, we are going to have the closing ceremony. But before that, but yeah, we're going to start around 4:05. I think we'll wait for more people to come for the closing ceremony. So now we'll have a short break before we start with the closing ceremony. So yeah, see you guys. We'll start at around 4:05.